Hi, welcome back to North Carolina Plumbing Code class. Today we're looking at Chapter 9, starting in venting. So last chapter we did was Chapter 8, the indirect and special waste. So I hope everybody did well on that quiz that you took there. And now we're into Chapter 9 on vents. So page 75 of the North Carolina Plumbing Code 2018 edition. So if you're on page 75, we'll go ahead and jump right in. The scope of this chapter is going to control the minimum diameter of vent pipes, circuit vents, branch vents, and individual vents, and the size and length of vents and various aspects of vent stacks and stack vents. Additionally, this chapter regulates vent grades and connections, height above fixtures, and relief vents for stacks and fixture traps, and the venting of sumps and sewers. A trap seal protection. The plumbing system should be provided with a system of vent piping that will permit the admission and or emission of air so that the seal of any fixture trap shall not be subject to a pressure differential of more than 1 inch of water column. So the purpose of those the vents is you're protecting those trap seals. It's going to help everything flow better as well. I mean, you think of if you took an old gas can, the style that had the little pop-up flip on the back, if you left that pushed in and you didn't flip that open, as you tried to pour gas out of the can, it would start to flow, but then the flow slows up. And if it was a plastic can, you'd even see the sides of the plastic can start to draw in a little bit. And then you could hear the water flow, the gas flow stop, and you could actually hear it just sucking air in. And then air would start to flow again. So it needed to replace that space as the liquid or the gas going out with air coming in. So if you flip the little flip up lid on the back, you created a vent. So as fuel goes out, it draws air in. So this says, but the vents is going to help it in both ways. Whether you've got a positive pressure or a negative pressure in the plumbing system, it's a vent's going to allow that system to breathe both ways, allowing air to be drawn into the system, but then also at times it will be allowing air to flow out of the system, and it protects all those trap seals. Every fixture has to be protected by a trap. That trap provides a liquid seal, and that liquid seal then in turn prevents the sewer gas emission into your house, to your building, wherever the plumbing is located. So where's venting required? Traps and trap fixtures shall be vented in accordance with one of the venting methods that's specified in this chapter. So all trap fixtures do need to be vented. Then your chemical waste vent system. If you have a chemical waste vent system, it needs to be independent of the sanitary vent system, and it's going to terminate separately through the roof to the outdoors of not less than 6 inches above the roof there, which is like a regular vent system, which we've already talked about. That going 6 inches above, if it's not accessible, which we'll talk about in a minute. But you've got to separate a chemical waste vent system and a regular vent system for a sanitary sewer. Okay, let's see. You do need to test your vents. They need to be tested in accordance with Section 312. Chapter 3 was general regulations, and one of the things that we found and we discussed in Chapter 3 was testing and inspection. So all of it needs to conform to the testing specifications there in Chapter 3. Materials, vents, they need to be, and then it goes down to 902.2.2.3. It's talking about the vent materials for those vent terminals, the roof flashings. If you had sheet copper or sheet lead, it kind of gives you some weights and stuff and specifications on those. Now, if you get to your state exam and you're looking at it, there's a couple different places that you're going to see as far as maybe sheet lead, sheet copper being referred to. So make sure to read the question and see what is exactly talking about. If it's talking about roof flashings, then this is where you're going to go. Some it might be talking about a shower pan liners, and you need to go find that under shower pan liners. Some of it's just going to say for sheet lead or sheet copper in general purpose applications, it needs to meet these requirements. So make sure that you go into the appropriate place for where the application where it's being used for the sheet copper, sheet lead. Vent terminals 903.1, the roof extension. Open vent pipes that extend through a roof shall be terminated not less than. Now, I know if you're reading this here, you'll see it just says what number of inches. Well, there was a number supposed to be put in there, 6 inches, but they did change up the wording a little bit. If you go to the residential building code and look at the plumbing section there, and you're reading this part, the vent terminal, it says they changed it to say 6 inches above the snow level. Now, I'm not exactly sure what the snow level for us here in the middle of the state of North Carolina is. We don't get a whole lot of snow, but we do get some. So if on your state exam it does say something there, you probably looking for it says 6 inches above the snow level is probably going to be your best answer there. Or if they don't have that, if they say 6 inches above the roof line, that's the answer that you want to go with on that as well. I normally just plumbing application, I'm going to stick that thing up. I'm probably going to get it about a foot above the roof is what I'm looking for. But I don't think if you get it at least a good 6 inches, I don't think inspector is going to turn you down. The main thing as far as really knowing exactly what the rules say here. It's more than just, am I getting my work passed? Your probably intention by going through the code class is to one day get your license. And so you need to know exactly what these minimums and maximums and everything are, just because you need to pass that state exam. So you're going to go with this. It says if it's not accessible, where the roof is to be used for assembly or as a promenade, observation deck, sunbathing deck, or similar purpose, open vents shall terminate not less than 7 feet above the roof. So if the roof is accessible and there's going to be some usable space up there, maybe there's service and equipment up there. It says, yes, maybe they got a sun deck up on there. So if any of those cases, all your vents coming up through need to be at least 7 foot above the roof. Okay. Flashings, where each vent pipe with the roof line should be made watertight with an approved flashing. Vent extensions in walls and soffits should be made weathertight by caulking. So if you come out the sidewall or down through a soffit material or something like that, it says you can just caulk around them with some type of waterproof caulking there, and then that will be fine. Prohibited use. Vent terminals shall not be used as a flagpole or to support flagpoles, television aerials, or similar items, except when the piping has been anchored in an approved manner. There you go. So location of vent terminals. An open vent terminal, so where the vent's coming out and terminating at, from a drainage system should not be located directly beneath any door, openable window, or other air intake opening of the building or of an adjacent building or property line. And any such vent terminal shall not be within 10 foot horizontal of such an opening unless it is 2 foot or more above the top of such opening. Okay. So where does the vent terminal have to terminate? 10 foot away or 2 foot above. What does that look like? Okay. Let's just say we've got a, what are we going to do here? Let's do some type of Cape Cod style roof to where they've got, let's just say you've got windows up on here. Okay, let's just say these are openable windows. Okay. So you got dormer windows up on top of here. Maybe in the upstairs, you're going to have a vent coming up. And maybe that vent's going to come up through the roof right here. If it is, you need to look to say from the edge of this window, this vent has to be at least 10 foot away. And if you didn't get it 10 foot away, you need to get it high enough to where that vent comes up and is or 2 foot above. Okay, vent terminals, 10 foot away or 2 foot above. Maybe you've got something that's coming out. And underneath this overhang there's going to be a lip. And if you look up under there, it might have little holes under that soffit material under there. So if you had a vent coming out the side of the house, You wouldn't want to vent that underneath this overhang if it had little slots in there that was a ventilated soffit. That sewer gas could come out and go right up into the attic space. So, but now it could pop out and then maybe turn up above the soffit to where you could get the 2 foot above the ventilated soffit, and then that would work for you. Okay? 10 foot away or 2 foot above on those vent terminals. It says extension through the wall, 903.6. Vent terminals extending through the wall shall terminate at a point not less than 10 feet from a lot line and not less than 10 feet above average ground level. Vent terminals shall not terminate under the overhang of a structure with soffit vents. Once again, we just showed that there. Sidewall vent terminals shall be protected to prevent birds or rodents from entering or blocking the vent opening. So we won't leave those vents to the horizontal. You need to be able to turn them back vertical. They do make little covers for them, little screen things, vent terminal caps and things that you can put on as well. Let's see, outdoor vent extensions. Let's see, a stack required. When is a vent going to have to go to the outdoors? Every building in which plumbing is installed shall have at least one stack, the size of which is not less than 1/2 of the required diameter of the building drain and not less than 2 inches in diameter. So this stack, where is the stack required? Every building has to have at least one main vent that's going to run out to the open air. Okay, one's got to go through either the sidewall, through the roof, meet those vent terminal restrictions that they've got on them, and go out. Okay, it can't be less than 1/2 the diameter of the building drain and not less than 2 inches in diameter. Such stack shall run undiminished in size and as directly as possible from the building drain through to the open air or to a vent header that extends to the open air. Okay, so this main vent, got to have at least one. Here's your main vent rules. Okay, 1/2 the diameter of the building drain. But no less than 2 inches. So the building drain, if you look back up under chapter 2 on the definitions, the building drain is the main trunk line inside, going from 10 foot outside the building in, and then everything branches off of. So that's the biggest line inside the building is the building drain. So when you're trying to size the main vent, you go 1/2 the diameter of the building drain. But let's just say the building drain is a 3-inch building drain. 1/2 of that is 1.5 inches. But the second part of the rule says, but you can't be less than 2 inches. So the smallest size that you can run the main vent right now is 2 inches. Now we're going to go on down to the next section. It says 904.1 says, where does that main vent have to connect to? The main vent has to come off of either the building drain, which is that main trunk line, or you can come off of a branch of the building drain that's not less than 3 inches in size. So where you come off of, it can't be less than a 3-inch pipe that you're connecting to on that. And that was 904.1.1. Vent stacks required. A vent stack should be required for every drainage stack that has 5 branch intervals or more. Go back to chapter 2 under definitions and look up what a branch interval is. Basically, it's going to be a floor level that has plumbing on it with at least 8 foot in between them. And it says if you have a drainage stack that has 5 branch intervals or more, you're going to have a vent stack. A little bit different than you just take the 2 words and swap them around, and it's 2 different things. Stack, vent, stack. Two different things. Okay, so there you might be a stack that's got drain lines, horizontal branches coming off of it. All right, and then the drain run out that way. 1, 2, 3, 4, 5 of them. And then above that, above that highest connection that's receiving, that's got some drainage coming into it, that is going to be called stacked vent. Okay, stacks vent. But now we've got one that's called a vent stack. It's just vent, and we need to put that in. Here's one possible location. We'll talk about the different locations of it. It's going to be a vent that's a stack itself, and vents can tie back over to that. So if you have 5 branch intervals or more, the building is going to require a vent stack. Okay. Let's see. Vent termination. Vent stacks or stacked vents shall terminate outdoors to the open air or to a stack type air admittance valve in accordance with 918. The vent connection at the base. Where does the vent stack going to connect? We already talked about the main vent, or that stack. Where's that going to connect to? And that's to the building drain, or a branch of the building drain not less than 3 inches in size. But now we're going to say, well, where does this one, the stack vent, connect to? And this is 904.4. Vent stacks shall connect to the base of the drainage stack. Okay, the base of the drainage stack. Here's the base. Let's look and say, well, where at the base? The vent stack shall connect at or below the lowest horizontal branch. So at or below, here's the lowest horizontal branch, or below. So in this area in here, okay. Let's see what else it says. At or below the lowest horizontal branch, where the vent stack connects to the building drain, the connection should be located downstream of the drainage stack and within a distance of 10 times the diameter of the drainage stack. So it says, yes, we can put it to the building drain, but it needs to be, everything's flowing this way, so it needs to be downstream of the stack. All right. And it says, and within, so as far as within 10 times the diameter of the drainage stack. So if you had a 4-inch drainage stack, so the vent stack connection, vent stack would connect to the building drain within 40 inches of the stack, of the drainage stack. Okay. So there's one possible. And it says, or you could also do this as an option here. Come off at or below and tie in right in there as well. That's an option for you. Okay. Let's see what else we got. Vent headers, stack vents and vent stacks connected into a common vent header at the top of the stacks and extend to the open air at one point should be sized in accordance with the requirements of 906.1. The number of fixture units shall be the sum of all fixture units on all stacks connected thereto, and the developed length shall be the longest vent length from the intersection at the base of the most distant stack to the vent terminal in the open air as a direct extension of one stack. So it's saying you could take one of these out to the open air. Well, this one can connect back to it. You can connect the two and take one out is acceptable. Okay. Vent connections and grades. Vent connections and grades. Be the next thing we take a look at. Connections. Individual branch and circuit vents shall connect to a vent stack vent, air admittance valve, or extend to the open air. So you can take, and we could pop as many vents through the roof that we wanted to. Now, of course, that's extra holes in the roof. So you might look at it and say, hey, well, these are close enough together. Why don't I just run one up and bring it back and tie it into another one that's going to go out, and I'll try to minimize some of the holes in the roof. You can do that. The grade, how much pitch have we got to put on that? They need to be graded and connected as to drain back to the drainage pipe by gravity. So maybe what you're going to do is, let's just say we've got a sink over here, okay? This comes out, there it catches our sink. That's back in the wall. There's our floor. Okay, there goes the drain goes down, out, here goes our vent. The vent goes up. But we don't want to, maybe we don't want to take that vent out right there, because maybe that vent, if we went straight up out through the roof, that might be on the front of the house. And we don't want to see that vent up on the front side of the roof that faces the street. So we might just say, well, let's just run that vent in the attic across the ways to the back side of the roof. And then we'll take that vent up and out. And we'll put appropriate roof flashing on it to get watertight seal. And we'll bring that vent up. Since it's not accessible, we'll say, let's get that thing 6 inches up above our snow level. All right, so it's talking about, how about the grade on the horizontal pipe that we run there? How much pitch do we need? Now, in chapter 7, we talked about grade on our pipes, but it was based on the pipe size. And if it was anything smaller than a 3-inch pipe, we said it's got to have 1/4 of an inch per foot drop on it. If it was between 3 to 6 inches, we said it had to have an 1/8 of an inch, and 8 and larger, we had to have a 1/16 of an inch per foot drop on it. That's not the case for vent pipes. All it has to do is have positive slope, or be pitched in such a way that we've got it sloping back towards the fixture it serves. So maybe if it rains and we get a little water down this pipe, it's going to drain down this vent pipe and just run down the drain. So yes, all you need is positive slope, sloping pitched back towards the fixture it serves. Okay, that's grade on the pipe. The vent connection to the drainage system. Every dry vent connecting to a horizontal drain shall connect above the center line of the horizontal drain pipe. Above the center line of the horizontal drain pipe. Vertical, here, let's continue on a little bit. Vertical rise of the vent. Every dry vent shall rise vertically to a point not less than 6 inches above the flood level rim of the highest trap or trap fixture being vented. I'll continue on. They do put a couple exceptions in there as far as vents for interceptors located outdoors. And then when vents for interceptors and isolated floor drains are not located near an adjacent wall, the vent can rise 6 inches vertically. It turns horizontally and continue to the nearest wall for cleaning purposes. A clean out the same size as the vent shall be installed. So you put a clean out on that vent there. Height above fixtures. A connection between a vent pipe and a vent stack or stack vent should be made at not less than 6 inches above the flood level rim of the highest fixture served by the vent. Horizontal vent pipes forming branch vents, relief vents, loop vents should be located not less than 6 inches above the flood level rim of the highest fixture served. So if it's common, what you're commonly hear is 6 inches, 6 inches, 6 inches. So that's what you really need to remember is 6 inches. But now you just say, well, but where's all these 6 inches we're talking about? All right. So if we are going to, let's just say we wanted to individually event a water closet. Wall. There's our floor level. Let's just say the water closet was going to be like this. Okay, so we got a water closet flange here. You come down, you turn out, and let's just say, oh, well, we'll run this back and turn it up, and we'll have a vent up there. Okay, go ahead. We got a venting that water closet. No, we cannot do that. Okay, this one is actually, I really should dash this. If there's nothing draining down it, that is dry. When you flush this toilet, it's going to flush this way and go down. It's sucking air out of the back of that. And you know what? That's going to work. That's going to work just fine for however long it is until we get something clogged. And if we clog this vent somehow, We don't have a way of unclogging it. I guess you'd have to climb and get your sewer machine up on top of the roof and run your snake down through the vent from up top to try to unclog that. Because if this gets clogged and things back up in this line, we can run a snake down through here and clean out this line, but it's going to follow the drainage line but leave the vent clogged. Okay, so we cannot lay a dry vent down horizontally, which that's what we're doing right here, which is not allowed. We cannot lay a dry vent down horizontally unless it's 6 inches above the flood level rim. So another case, kitchen sinks are often located with, maybe you might see a nice window above your sink. Okay, so you can wash your dishes, look at the kids, see the kids play in the yard or whatever. So if we had a trap come down out of this one and it went back into the wall, but we said that back in the wall, that drain's going to go down through the floor. To get it to go down, we got to go up with a vent. And then you say, oh no, our vent's going to be in that window. So we got to get out of the way of the window. So we cannot do this. We just turned a dry vent down horizontal below the flood level rim. Where's the water going to come out and flood the house? The flood level rim. Okay, top edge of that kitchen sink. We cannot lay it down unless we can get 6 inches above. Now, if it's 6 inches above the flood level rim, we can lay that down. But here's something else we can do. If you're like, oh no, well, maybe I can't get that thing. The window comes too low. I can't get 6 inches above. Remember, you can't lay it down horizontally. A 45-degree angle. If you look up the terms, horizontal pipe and between horizontal and vertical, a 45-degree angle is included in vertical. So actually the pipe is still turning vertically if we went there. And we could take that 45 and that can be below that 6 inches below the flood level rim on that one. Now, there was another part that was mentioned in that other section that was 6 inches. Let's just say we had, okay, there's a fixture and it's vent. But now we've got, that's on one floor level. Maybe we've got a vent coming up from another, with the lower floor level. And we want to tie it back and just say, well, I'll connect it to this vent and let that vent out. Well, you can connect the two vents. That's fine. But here's the flood level rim. This vent is serving this fixture. So in order to make this tie in, we need this vent to rise and to make its connection at least 6 inches or more to that to where that ties in. Okay, well, just tie it up with a little sanitary T fitting right there would be fine. So you can make that connection, but just 6 inches. So when you're talking about laying vents down horizontal, I've got 6 inches above flood level rim. I'm going to connect one vent back over to the other 6 inches above that flood level rim on those. It did have the exception saying remote floor drains and saying, but why there's no way around it. Then it says, well, just take the vent coming up, rise 6 inches, run horizontal until you can get to a closest wall. Then go up with a vent, but you're going to have to throw a clean out on the vent. Just in case something gets clogged and that vent gets clogged, we need to be able to have a clean out so we can open that up and snake that out. Okay. What else do we have here? For future vents, where the drainage piping has been roughed in for future vents, a rough in connection for a vent shall be installed. The vent size shall not be less than 1/2 the diameter of the rough end drain to be served. The vent rough end shall connect to the vent system or shall be vented by other means as provided for in this chapter. Connection shall be identified to indicate that it is a vent. So, actually, I just did one like this the other day. Ran an underground, put the in a new home going up, but they're not finishing out the basement just yet. So I just capped all the lines off. And so for a bathroom, it's going to have a bathroom a bath and a half downstairs. It's got a laundry room connection and all downstairs. So I've got all this stuff roughed up for planning. But really all we're doing is finishing the main level and then the upstairs. So right above that area where there's going to be for the downstairs where it's all just come up and capped right now, up above that, I've got double lavatory sinks, okay, and a vent going up. So what I did is, if this is the flood level rim, I came off of that, and I'm at least 6 inches higher than the flood level rim. I put a T. I came over a little ways, stayed out of the way of electricians and anybody else's stuff. But I took that vent, and I went down below the floor, and I put a permanent PVC cap on that, glued it on there, and on the side I wrote future. You write future vent. Okay. Now, so downstairs they've got all these plumbing pipes coming up, stubbed up through the floor. They got them here and here and here, and I'll cap them all off. Future drains. But since I have future drains, I need to run one down, cap it off, and label it future vent. So that when I rough these in at some time later in the future, I've got a place I can run over and tie those vents up. Okay. I need to make sure that that's going to be half the size of the drain that it's serving. Okay. Let's see what else we got. Future vents. Vent pipe sizing, section 906. Okay, how much more we got on this thing? All right. Vent pipe sizing. I'll go a little bit more. I'm going to break this actually into 2 sections. Following after this one, you will not take the quiz this week. Wait for part 2 to come out. Okay. And after part 2, I've got a 20-question quiz that I'm going to be giving you. And then after part 2, and you watch part 1, part 2, reviewed for it, then you'll have a quiz. So, but we'll go a little bit further today. Vent pipe sizing, section 906 on page 76. The minimum required diameter of stack vents and vent stacks shall be determined from the developed length and the total of drainage fixture units connected thereto in accordance with table 906.1. But in no case shall the diameter be less than 1/2 of the diameter of the drain served or less than 1 1/4 inches. Okay, so it does give you 906.1. Okay, and on page 77, you see a chart that looks something like that. All right, it says that you can size them according to this chart, which is it's determined from the developed length. Developed length is in chapter 2 the distance measured along the center line of the pipe and fitting. So if I was measuring this developed length, wow, I got a bad lean on that drawing, don't I? Must have been standing here to lean. Okay, I've got you would measure center line of the pipe and the fittings right on out. Okay. Now that I really noticed that by looking at the screen, I got to get that off there. That looks pretty bad. So on the left column, it gives you the diameter of the soil or waste stack, okay, that you've got, the diameter of the stack. Go over one column, it's the total fixture units being vented. So you take, in chapter 7, we talked about drainage fixture units. Lavatories are worth 1 DFU. You had bathtubs worth 2, showers worth 2. we had water closets worth 3, laundries are worth 2, kitchen sinks worth 2. So you took it and you can add up all the DFUs that are being vented through that stack. And then you look over there, it's got a maximum developed length of feet. Okay, and then also the diameter of the vent. So the maximum distance, maximum developed length is in there. The diameter of the vent. So the diameter of the vent is the ones at the top: 1.25 inches, 1.5 inches, 2, 2.5, 3, 4, 5, 6, and so forth. So if you had, let's just say we have a 2-inch diameter waste stack, and we've got 8 fixture units being vented. You could look at that, and right in this case, it says that you're going to have at least 1.5 inch vent with, and then it says the diameter, the developed length can be up to 75 feet. If you go over 75 feet with 2, you can go up to 200 feet on that. Okay, so it's got the maximum developed length in there. The maximum developed length, the little footnote A, shall be measured from the vent connection to the open air. But in no case shall it be less than half the diameter of the drain of the fixture, the largest drain served, but no less than let's see, this is going to be size of stack vents and vent stacks. In which also, when you get down to 906.2, vents other than the stack vents are vent stacks. It's going to be vents is going to be half the diameter of the drain served, but no less than 1.25 inches. Right on that one. Okay. Now, don't forget that when you're sizing your main one, you're on 904.1. Half the diameter of the building drain, but no less than 2 inches in size. This is dry vents other than that main, half the diameter of basically the largest drain that vent is serving, no less than 1.25 inches on that one. Okay. Also 906.2, there's some other places that are going to say it as well, but also mentions here that the farthest you can run a vent at its minimum size is going to be 40 feet. 40 feet in developed length. If it goes over 40 feet, you have to increase that vent size from where it started by one pipe size up. Okay. Increase it by one pipe size. All right, let's see. Developed length. Let's see, multiple branches. Where do I want to talk about? Sewage pumps and sewage ejectors other than pneumatic. Drainage piping below sewer level should be vented in the same manner as that of a gravity system. Building sump vent sizes for sumps with sewage pumps or sewage ejectors other than pneumatic should be determined according to 906.5.1. An open vent terminal from a drainage system should not be located directly beneath any door, openable window, or other area intake. The building of adjacent building or property line as such vent terminal should not be within 10 feet horizontally or such of an opening unless it is at least 2 foot above. And that just kind of backs up what we were talking about before. But of course, this is on sewage pumps and injectors as well. All right, let's see. And then you get table 906.5.1 is the chart for the size and length of sump vents right there. Size and the length of your sump vents. You got the discharge capacity of the pump in the gallons per minute. It's listed over in the left column. You've got the diameter of the vent coming across the top here. 1.25, 1.5, 2, 2.5, 3, and 4. Maximum developed length of the vent. Some of them will say no limit to it. Yeah, then you have feet. How many feet that you can have, and then some say that it's not permitted. Okay, so you're reading that. Let's see, vents for stack offsets. Vent for horizontal offsets of drainage stack. Horizontal offsets of drainage stack shall be vented where 5 or more branch intervals are located above the offset. The offset shall be vented by venting the upper section of the drainage stack and the lower section of the drainage stack. So you had a stack coming up, drainage running into it. You did an offset, vertical up, and you got more coming off of there. So you got a vent coming off the lower and off the upper section of those. Okay. The upper section of the drainage stack should be vented as a separate stack with a vent stack connection installed in accordance with section 904.4, which we talked. The offset should be considered the base of the stack. So letting that offset. So just saying, basically, they're going to just let you saying we're going to vent this stack, kind of separate as venting this one. You're going to do your vent stack just like we've already talked about and making the connection. They're going to say you're going to call this the base of the stack. Okay, the offset portion is going to be considered the base of the stack, where you could. Within 10 times within 10 times of the diameter of the stack is going to be connection of this vent stack there, and you're going to vent both the upper and the lower. On that lower section of the drainage stack should be vented by a yoke vent connecting between the offset and the next lower horizontal branch. The yoke vent connection shall be permitted to be a vertical extension of the drainage stack. Vertical extension of the drainage stack. The size of the yoke vent and connection shall be a minimum of the size required for the vent stack and the drainage stack. And then you can end up tying those back together. Relief vent stacks of more than 10 branch intervals. All right. So we've got at least a 10-story building here with plumbing fixtures on each floor level. And it says, a soil and waste stacks in buildings having more than 10 branch intervals shall be provided with a relief vent at each 10th interval installed. Okay? But you begin counting them from the top floor and going down. You don't start at floor 1, 2, 3 and go up. It's going to say every 10, but start at the top and start to work your way down. With a relief vent at each 10th interval installed, beginning with the top floor. Now 908.2 talks about the size and connection. The size of the relief vent shall be equal to the size of the vent stack to which it connects. The lower end of each relief vent shall connect to the soil or waste stack through a Y below the horizontal branch serving the floor, and the upper end shall connect to the vent stack through a Y not less than 3 foot above the floor. Okay. The lower end of each relief vent shall connect to the soil or waste stack through a Y below the horizontal branch serving the floor. Horizontal branch. It serves the floor. You've got a vent. This is the vent stack going up. Here's your soil stack or waste stack. You've got it coming across here. The difference of soil and a waste, just in case you don't know, if you go back to chapter 2, soil is going to have some type of fecal matter or some toilets or something tied to it. So a waste might just be sinks, showers, something like that. Not the fecal matter. Okay, but let's see. So doing it, it's got to be, the size is going to be the same as this size. Right, there's going to be a relief in it. You started with the top floor and counted your way down. And you come to the lower end of the relief vent shall connect to the soil. So talk it through. Connect. It's going to connect to the soil or waste stack through a Y fitting. Okay, so try to form as you're reading, try to form the picture in your mind or start to draw this out as you go. You said there's the stack, there's the horizontal branch. So connect through a Y below the horizontal branch, serving the floor, and the upper end shall connect to the vent stack through a Y not less than 3 foot above the floor. So if you came off with that and that vent goes up and is going to connect into here, you've got to have at least 3 foot minimum above the floor before it ties back into your vent stack. And that is your relief vent. Your relief vent, or if you have 10 floors or more, and it's starting by counting floor 1 from the very top and starting to count your way down. Okay? Fixture vents. Let's see, how are we doing on our time? Okay, let's cover this one, and then we'll pause there. Fixture vents. Distance of the trap from the vent. Each fixture trap shall have a protecting vent located so that the slope and the developed length in the fixture drain from the trap weir to the vent fitting are within the requirements set forth in table 909.1. Exception: the developed length of fixture drain from the trap weir to the vent fitting for self-siphoning fixtures such as water closets shall not be limited. Okay, table 909.1, maximum distance of fixture trap from the vent. So now we're getting into that bit of information that I normally talk about. One of the first days of getting stuff down in your notes, when we talk about every fixture have to be trapped. So we talk about P-traps and all the parts and everything about those. We said it, and then we talk about every trap has to be protected by a vent. And we talk about the different kinds of vents, which we'll start to get into this in part 2, individual vents, common vents, wet vents, vertical wet venting, some of the other venting methods. But now this one is talking about, this chart was going to give you distances. It's going to say, and we looked at this trap to vent information. Okay, trap to vent information. So this one gives you a max, that chart 909.1 gives you maximum distance of fixture, the trap from the vent. So if the size of the trap is 1.25 inches, the distance from the trap is 5 feet. Okay, and this is maximum. Now, if you remember, I always put minimum distance, maximum distance, and then we talked about also minimum amount of fall in between here and maximum amount of fall between this trap to vent. Okay, so table 909.1 is hitting this piece of information, the maximum distance. Remember how we said you did it? You took the trap size. So let's just say this was for a shower that had a 2-inch trap. The maximum distance from trap to vent with a 2-inch, we said, is 4 times the pipe size. 4 times the pipe size in feet was the rule that we followed. 4 times the pipe size in feet. Now, in this case, so if you look at this chart, you take the size of the trap, multiply those by 4, and that's going to give you the answers for all of those. So take the size of the trap, multiply it by 4, it'll give you the answer. Now, then there's another, the venting the fixture drains. The total fall in the fixture drain due to the pipe slope shall not exceed the diameter of the drain of the fixture drain. So, which was this piece of information. What's the maximum amount of fall? The diameter of the pipe. So the rule for this one is the diameter of the pipe or the drain. So if it was a 2-inch trap and drain, the maximum fall between trap to vent is going to be 2 inches. The maximum distance, the rule for that, 4 times the pipe size in feet. The answer is going to be in feet. Okay. The minimum distance. 909.3 covers the minimum because it says crown venting is prohibited. It goes to tell you that crown venting is when you take the vent and put it too close to the crown. So when you slide it up, and so I say, well, what's the minimum distance? How close can that be? If I get more than 2 times inches, 2 times the pipe size in inches, it's not allowed because it becomes what's called a crown vent. So we said, what's the minimum distance? 2 times the pipe size in inches. So 4 inches would be, in this case, because we're working with a 2. So it's 4 inches is how close it could be. Otherwise, if it's closer than that, what do we call it? A crown vent. And crown venting is illegal. What's the maximum distance? Due to the pipe, 4 times the size in feet. Now, the minimum amount of fall that we can have, also in table 909.1, it gives you the slope requirements again. Chapter 7 gives us the minimum slope requirements on a piece of pipe. So what we have to do, it's just a slope problem. And you have to be able to work the slope problem. So what's the minimum fall? Well, if it's a 2-inch pipe, we're going to have a 1/4 of an inch drop per foot. So if our pipe from the trap to the vent was running 2 feet, we're dropping 2/4 because we're dropping a 1/4 for every foot, but the distance is 2 feet, so we got 2/4. So the minimum amount of fall is going to be 2/4 of an inch, which is, we reduce it down to say 1/2 of an inch. That's on that. Okay, and that's where we're going to stop it. We're going to stop it with that familiar piece of information that we had there. Next time we'll pick up and we'll do part 2 of chapter 9, and then we'll have, I think we covered more than halfway through. So next time we'll go through, we'll finish that up, and then we'll also review for that chapter 9 quiz that you'll take after you watch part 2. So don't jump in and take it right away. Hold on, wait until you watch the second video, then take the chapter 9 quiz. You'll be the most prepared and ready for it. So, okay, well, enjoy the time with you. If you've got any questions, let me know. And I'll look forward to seeing and talking with you later. Have a great rest of your day.